Hi guys, today's Leetcode daily is zero array transformation second. So in this question we are given an integer array nums whose length is n, and we have a 2D array queries where queries of I is equal to li ri val I. Now in this nums there are some elements. Currently they are positive integers. Now we want to convert this nums array into zero array. That means all the elements of nums should be equal to zero. So how we'll do that? For doing that, we'll perform some query. In each query, we'll select two indices. One is left index and right index, and all the elements in this range. For all the elements in this range, we'll subtract at most val of I from that. Now we have to return k, which is the minimum number of queries needed to convert nums to zero array. And if no such k exists, then we'll return -1. Now we'll see example to understand this question in a better way. So here this nums array is given and these are the queries. So we'll see first query. In first query, we are selecting 0 index, second index, and from this range we'll delete -1. After performing this query, we got 101. Still it is not zero array, so we'll perform some more queries. In this also we'll select 0th index, second index, and all elements in this from all elements in this range we'll subtract -1. Now we got z- zero array, that is all the elements in nums become 0. So we'll return k equal to 2. Now we'll see brute force approach. So we'll simply traverse in queries vector and perform query. After each query, we'll check whether we get zero array or not. If any time we get zero array, we'll return the count of queries performed till now. But if we'll see if the queries vector is of size q, then traversing in queries vector will involve Vigo of Q time complexity. Then performing that query also will involve, in worst case, Vigo of Q time complexity. And checking whether we get zero array or not. If there are n elements in nums, it will require additional Vigo of n. So overall Vigo of n into Q time complexity will be, as per our given constraints, both n and q can go up to 10 to the power 5. So n Vigo of n into q time complexity is not feasible. So we'll think something better. Now we'll see difference array concept. So in this, we are given a difference array of size n, and initially all the elements are equal to 0. Now we have some queries to perform on the range. So in each query, we'll add some element at a given index in the given range. Now after performing all the queries, we have to return the final array. If we'll try to do in the brute force way, traversing in the queries and performing each query, then it will take n into q time complexity. But can we do something better? So here we'll just add value to the left index and delete value from right index +1. And when all the queries are completed, then we'll do prefix sum to get final array. So we'll see example like this was the initial difference array. We had a query from 0 to 2. In all elements we have to add 1. So instead of adding 1 to all the elements in the range, we just added 1 at the left index and subtracted 1 from right index +1. This is done so that the effect of this 1 gets nullified after right index +1 when we do prefix sum. And then afterwards we do prefix sum and we get the final array which was supposed to be. Now we'll see how we can implement this in our question. So what we'll do, we'll take a difference array with all elements 0 and add value for each query. And if any time all the elements of difference array becomes greater to the respective elements of nums, we can say that this is a valid solution. So our question is that we are given nums, we'll subtract something and we'll make 0. But we just did reverse. We took a 0 array and performed some addition, and whenever all the elements of the current 0 array it becomes greater than nums, then we know it is a valid solution. So we'll just count number of queries needed for this. and we'll return that count. But if we'll do brute force way, perform all the queries, and after every query find prefix sum, then it will take Vigo of q cross n. But what if we apply binary search on finding the number of queries needed? Then it will take just Vigo of n cross log q. So we'll see the code to understand how we can implement this. Now this is possible function will tell us whether it is possible to make zero array by performing k queries or not. If it is possible to get zero array after k queries, then it will return true, else false. So simply we are taking difference array with all elements 0. We are performing k queries for each query. At the left index, we are using adding the values, and at right index plus 1, we are subtracting that values. After these all k queries are over, we are just doing prefix sum so that we can get the current difference array. Now if any at any index in difference array the element is less than the respective element of nums of I, that means we cannot form zero array, so we'll return false, otherwise we'll return true. Now we'll understand the implementation of our main function min zero array. So we take q and initialize with queries dot size. Now we take low equal to 0, high equal to q, and k equal to -1 in case if we don't get any answer. So we have to return k equal to -1. Now we apply standard binary search. We find mid. Now if we see if with mid number of queries it is possible to get zero array or not. If it is possible, then this mid can be our answer. So we'll store it in k. Since we want smallest k, so we'll do high equal to mid -1 to see if any further smaller value of k is possible or not. In other case, if with mid number of queries it is not possible to get zero array, so with queries less than mid it is definitely not possible. So the elements between 0 to low are 0 to mid are waste. So we'll do low equal to mid plus 1. When this loop will be over, then k will contain our actual answer and we'll return the value of k. Now we'll see time complexity and space complexity. If we talk about time complexity, in this loop, this for loop will run in worst case we go of q, because at most q queries can be there, and this though we go of n only. So overall here time complexity is big O of n plus q. This is standard binary search. So here time complexity is big O of log q. So overall time complexity will be big O of log q into n plus q. And if we talk about our space complexity, then only difference array we are using. So it is big O of n. If you understood this video, then please like, share and comment on this video and subscribe my channel for more such content. Thank you.